happened was that we actually went out, we picked something in the service catalog. Service catalog, it pulled the source code on up, and what we did is typically what happens if you've ever used Docker, Docker has this thing called a Docker file. Docker file actually defines how you install the product, how you move your source code in your environment, all those type of things. Now, when you typically work also with Docker and you also work with the orchestration engine Kubernetes, you have to write all these YAML files, right? And so this really tells you where the source code is, how to package it, how to provision those images out in the environment, right? So what we did from that standpoint is that Red Hat went and built this thing called source to image. And what it does is that it does all the automated kickoffs between getting the source code, packaging it in the right environment, putting the right Java EE configurations in the app server, and then builds the Docker image of the Java EE app. And that is actually what gets stored into the Docker registry. And then for the Docker registry, it actually gets deployed out into the various containers out in the environment, right? So what we did was that, just to break that down, is that when I first created the application, you'll see that it actually went through a build system, right? So this is the builds from that standpoint, right? And this is where it's saying, look at this git URL, pull that git URL source code on out, and then it builds as the Docker image. So that's what happens at the output of this. And then it went on out and did the second step, which is deployments, right? So yet again, this is something that you don't typically see in Docker itself. This is something you have to roll your own. This is what OpenShift provides out of the box, right? And once that happens, then you see is the application. So here you got Ticketmaster up and running, and you can go and click at it and whatnot, right? Any questions about that?
Yeah, what broke?
So I am not sure what exactly broke, to be honest, in the environment. What we did was that actually I'm running it locally on my machine. It's a Vagrant image. And if you guys have ever used something like Vagrant, it does a lot of monkeying around in the background. So, all I can say is that I did it twice before I showed up today at Starbucks to make sure it all worked for you guys, and the third time now it blew on up.
So you just took it off the network.
Yeah. So now what I did was I took it off the network, and then I rebuilt the image, and it seems to be off the network. I'm able to go a little further, so that's kind of interesting in itself. So the next thing what I'm going to go do is actually the developer. So now we've provisioned out the base application. Now what is the developer experience from that standpoint? We actually provide you with several different ways for you to push an application into the environment itself, right? So you can go and use the source to image that I mentioned about that. But if you have an application that has been Dockerized, so you're talking about something like say for instance you have a Hadoop distribution, or you have Oracle database, or we've had people who do WebLogic. If you can make it into a Docker image, you can also provision that out into the environment itself, right? If it runs on Linux, basically with some modifications, you can go and Dockerize that, right? So what I'm going to go do, I'm going to go into the CLI, into Eclipse, the IDE. I'm going to make a quick code change, and I'm going to launch is the Git hook that will start the rebuild of a new Docker image, and then have that provision out into the environment. So going back to Toolbox. Oops. Right. So that launch is Developer Studio. Yes.
What do you use for your build system? Is it,
Well, we're using just Git hook right now.
but I mean, what's, Yeah, what's driving the actual build? What's defining the dependencies of using like Maven or?
Yes, yes. So that's a good question. What I was trying to show you in the build system was actually the running logs behind the scenes. So let me see if I can get that up for you. Right. So this was actually what was behind the scenes. So remember I said there's two steps. Once I picked the template, right, there was a build step and a deploy step. The build step here is what was running behind in the background. So what happens is that our source to image process is opinionated, meaning that as long as you have the Maven file placed in the right places, you also have, say for instance, the server XML, the environmental variables, all that other, it's staged in the right places that we tell you to go and put it in, it will automatically build the Docker image with the right type of features into the product itself. So going into editing one of the files here, I will go into monster. Apologize for such a small screen. Source, main. So this is the main file on the front page. Right now it just says ticket master or JBoss example. So if I just type in ResNet and I save the file, right, I am going to go and check this into Git. And I will push and commit. You'll see that it has a mechanism in there that says message detail. It's going to trigger is an OpenShift build. All right, and I just push OK. If I look back at the status, so I can go and get pods. So what happens even behind the scenes, right, is that you'll see right there it says monster build 2. So what happens is that OpenShift, what we do is that we actually spin up a new Docker container, put the source code in there, do all the Maven build, make the EAR file, all in another Docker container, right? And once we have is the image file, then we insert it into the Docker container, put it up into registry. So it's never impactful to your normal kind of environment that you would have for dev, staging, production, and whatnot. Right? And so this will keep on running. Usually we have to go and see it has exit code in there, right? So then you can kind of see that, oh, okay, we've got the second build is done, right? We also have is the deploy. That has happened, right? And if I refresh this, whoops. Like I still have some trouble from that standpoint. Oh, now you can see that it shut the code up into the environment and shows that's ResMap, right? So, that's just a little example, right? Obviously, you can change any of the source code, right? You can load up new Java classes, however you see fit. The other examples have this Node.js, whatnot, right? And then every single time you make a change, you can then build out as a brand new image as you see fit. Right. So a lot of people, what they go do is they also ask a lot to do with the last piece, which is the scalability, right? So when I talked a little bit about the application containers, right, the density that you have, how do you actually scale this application, right? So we actually have two ways for you to scale the application. So one is that as part of the provisioning aspects of OpenShift, right, I mentioned there's an SDN, right? We actually provide as HA proxy in front of the, as an IP sprayer, right? If you push against the proxy, it will automatically provision more Docker containers to go and meet capacity, right? That's one aspect, right? So the easiest one is just throughput, which is most of the web traffic. But if you have other type of mechanisms like Hadoop, for instance, right? You can change the algorithm to be based off of CPU utilization if you want, right? So there's just different ways for you to go and determine at what point where Kubernetes will go and provision more and more of the environment itself as needed, right? So if I went back to go and scale, so if I go back to the example itself, this is that console yet again, right? So you have, see one container that's running, right? If I go here, and I will go and, let's see here. Oh, no I don't have that. So OC, scale. Sorry, I have a cheat sheet.
So is this also scale affecting the HA proxy, and that way is basically scaling up?
Yeah, so what basically the question was is that how is this related to the HA proxy, right? So what happens is that what happens is that HA proxy would automatically contact Kubernetes to provision more containers, right? But what I did on the command line is I forced it to become how many replicants there is, right? And Kubernetes will automatically make sure that it's compliant to whatever goal it is. So you kind of saw that I just go and created now, there's 2 containers, right? So if I wanted to go, let's do something crazy. 20 containers, right? It's just pod scaling. See pending from that standpoint, there's pending because it's going to go and add more into the environment, right? So what happens is that it's actually going and talking with the Docker registry, which holds all the Docker images, automatically pull that all out and then provision as fast as possible into the environment itself, right? And what it does is that Kubernetes has this concept of tagging. So tagging, what it does is that it places the algorithm to say, this is the current rack it's at, this is the current data center. So spray it across 3 different data centers, spray it across 5 different racks so that you'll have resiliency around the environment itself, right? So you can kind of see it's kind of going, right? So actually this instance that I'm running off of my own laptop, to be honest, it's only 4 gigabytes of RAM. So I'm kind of maxing out on the amount of RAM that is in the environment. But I wanted to show you a little bit about how fast it was easily to go and scale the environment, because when you have is the Docker image itself, right, all you need to do is just load that and run the process, the container to go and make it live from that standpoint. Yeah. So let's go. Actually, let's go and tune this down a little bit. So now.
So the load balance will distribute the loads according to those approved.
Yes, so what happens is the algorithm that Kubernetes is using is determining what is the placement strategy.
Is it a round robin?
No, it's not actually round robin, it's based off of tagging, right? So you can tag it as a tier 1 data center, a tier 2 data center, however which way you see fit, right? So now I'm going to change the replicants back down to 5.
Question, Alan.
Yep.
So let's say your application in our house needs to connect to a remote service that's running in another managed container. So what mechanism is there to bind your application to that remote service?
Yes. So the question that was is, what if you have two different applications, right? And application A had to talk to application B, right? So you gotta ask a really good question. There's actually a more subtle answer that I kind of skipped over the demo itself. That was more of a advanced question. So you'll notice that the way this is described is a pod, right? I didn't actually use the word container itself, right? So what we found was actually if you run Docker containers, say for instance there's applications that need to be co-located together. One example is like MySQL, right, with SQL, right? So that's the web GUI for the MySQL server, right? But if each application is in its own IP address, then you have a problem, which is like this IP address is trying to talk to a remote instance of MySQL, right? So a pod was created to sort of say this is a logical grouping of multiple Docker containers. So what happens in that case is that the MySQL and MySQL database service share the same IP address. So that can scale out horizontally. So that's one way that you can go and have all the applications talk to each other, right? And primarily, you're thinking of it much more as a unit of scale. But what if you had a application that was dependent on multiple services, right? So you had application A and application B, like two web services, two independent from that standpoint, right? So what I didn't show you, and I kind of skipped inside of the demo itself, is we talked about this idea of immutability. How does it really know one system to another system, right? How does one pod or a set of containers know itself, how it knows its current environment and where to go next? So what part of the magic secret sauce is OS environmental variables. So what happens is that when the Docker image is actually being created, there's a place where you go and set up all the environment variables. And so one part of the environment variable will say, here's the virtual IP for this application cluster, right? So here it's a monster demo is the virtual IP, right? So that entry point here, that's what's associated with HA proxy and then federates out to multiple containers, right? If it needed to talk to e-commerce payment service, right? How would it know from that standpoint? If you can't change the code inside of the Docker image, how do you do it? So what you do is you create a new environment variable called external service or whatever, payment service or whatever it is. Kubernetes injects that variable into that environment. The environment variable, along with the application code and all the other environment variables, gets compiled into a Docker image, right? So what happens is that the application references OS variables, right? And it knows that this is the service it needs to call out to. It also knows that if you promote that same environmental variable between dev, UAT, staging, and production, you haven't changed the application of code itself. The OS environment variable knows that you're talking to payment service 1 dev because you're on dev, and then that same image now in UAT, the OS environmental variable is, payment service UAT and so forth, right? So that's how you keep the image clean and pure, even though you can move and change around the parameters of how the application is running and connected to each other.
Is there a programmatic technique that you would apply to access these variables?
env:// Java props, right?
So now we're all used to using, like Spring has a configuration mechanism, OSGI has ways of passing etc values through.
Yes.
You have to change that.
Well, there are frameworks to go and help you to go and point and reference those codes so that you can go in there. So there is some bootstrapping that you got to go and do from that standpoint to do it from that. Because what happens if you hard code the environment, where are you going to hard code it? Or if you hard code it in source code, it will be bundled as all the Docker images will have that, right? So you can't store anything that is hard-coded that you don't want inside of the image itself. So then it has to be stored outside of the environment, right? And that's more of a best practice, right? Now, I've seen some other companies that when they first use Docker, the easiest way for them to go do it is write a Docker file, and they put everything in the Docker file. And then what happens in Jenkins, or they use Ansible, Chef, and Puppet, in the next environment, they basically go and use the exact same thing and recompile a brand new Docker image, right, with the new OS environment variables, and next when you do it, and now you have like 2 different MD5 hashes, a third MD5 hash, right? So you can honestly say maybe the code is the same, theoretically, if you do the control point from the source control. But the thing is that now, you know, you're not buying anything, right? You're literally, each Docker image in itself is per environment, per use, per, you know, instance from that standpoint, right? And that's where you want to get out of, right? Because at the very end of the day, if you use something like immutable containers, and this is maybe, you know, a vast topic from that standpoint, think about the code coverage. Dev 1 already covered maybe 80%. Dev 2's testing team, do they really need to go and cover the same 80% that was done on the first pass? It's the same image. What's truly different? It's the OS environment variables, right? Now you've reduced your test, you know, the amount of testing that you need to do with the same type of code coverage if, you know, all things are considered equal. Right. So I also had other examples. You saw me kind of do a cheat sheet from that standpoint. This is actually a stock demo that I have, right? But we have a lot of other features in the product itself. A lot of people ask for things like rollbacks, right? Because all the Docker images are essentially in repo, and the way that the repos actually work, it looks like Git. Right? So I can say, I want this build of the Docker image to be promoted to production, right? Which is like this hashtag. It looks kind of like a hashtag, right? Or this one gets put into this image, or, you know, dev 1, dev 2, I want build 153 on that, dev 3, I want 161 there at that fix, whatever it is. So you can replay, and when you have some of your manager says, can I get the same build that broke last week? Can I get the exact same environment? Now you can promise it because you have the Docker image that was deployed in that point in time, right? The other things that you might want to care about is how you do debugging, right? The nice thing about it is that in Docker itself, I kind of mentioned it's open port, all this other type stuff, right? So you have to build your own VLAN if you have your own Docker solution. In OpenShift, that's already defined for you. So what happens is that you install a client on your own PC, and you basically do a port forward. And so your IDE can connect to that remote port, and you do the debugger, and you can do all the things that you would typically do as if the environment was installed locally on your machine itself, right? There's a bunch of other scenarios in terms of CI/CD, right? You saw me use is the Git hook from that standpoint. Most of our other customers actually go and have something like Jenkins to launch that on up. So they'll maybe do the build themselves, or maybe they'll punch out to Jenkins from that standpoint. And then the deploy step is not from Jenkins, right? The end of the Jenkins process is to create as a Docker image and load that into OpenShift, of which then the build now can go and do it, right? And also from that standpoint, is a lot of our Docker repos are actually replicated. So if you have two data centers from that standpoint, it would automatically post to both of those data centers. So what happens is when you provision a brand new application, it would automatically go in terms of priority to the nearest repo to go and image or place that piece of software, right? Now, the other thing that you might ask a question about is, really, Albert, it's great that you're talking about infrastructure and whatnot, right? But how do I get my application, right? So I talked a little bit about the source to image. That's a little bit unique of what Red Hat actually provides, and we provide it for all all of the Red Hat products, the JBoss products, we have that source to image capability. You can also reuse it for other types of applications, right? But the other value add is that what you're going to go find is a problem with Docker itself is, have you guys ever gone to Docker Hub? Yeah, Docker Hub, right? So Docker Hub is where everybody kind of stores their Docker images from that standpoint, right? But if you do Docker pull MongoDB, there's like 100 installations from that standpoint. You don't know the how to verify that that is actually one that isn't one that's been played around with, right? You might be loading in code from who knows where, right? So OpenShift has this concept of having your own Docker repos. So what eventually most of the customers that we have, they'll have is Red Hat provides as a Docker repo for all the Red Hat supply products. Then you would have your own repo of whatever images that you go and build. And then you also have a third maybe set of repos that is public, right? From that standpoint, right? So you can mix and match as you see fit from that from that. I kind of jumped over various pieces. You know, any questions about the developer workflow process? Right.
I'm not clear, but so you have a MySQL image there and a SQL Server image, and so are those two different images? Or?
They are two different Docker images. So if I looked at the catalog itself and typed in the command, you'll see like basically one file for every single of those. So what happens is that in Docker, there's this command called docker load, right, which basically loads those as those. So the way that you have two options to get Docker images, right? One, you go to Docker Hub and you download the image and then it installs on your machine. The other one is you do speakerware. You put it on a USB key, you copy it onto the other machine, like this machine, and you do a Docker load, and then it loads whatever Docker images you have in your USB key from that standpoint, right? So our difference here is that because we're Red Hat, we actually provide is a whole bunch of different Docker images for a lot of the open source products, and then we partner with other third-party companies like Hortonworks and whatnot, and they provide the Docker images for their products, right? But I think what you're going to see is that right now, I think if you go to Docker Hub, it's like some insane amount of images that are out on there, 10,000, 20,000, 30,000 images from that standpoint, right? Because what people are looking at Docker at the very end of the day, even though we showed it in terms of how easy, you know, like we talk it from a developer point of view, right? Immutability, a way for us to get source code, single environment that's used in dev all the way to production, right? The admin side of the house, they're like looking at Docker and they're like, this is an easy way for me to install apps. It's just one way for me to install apps regardless of platform, right? It's the new install shield, right? And that's a lot of how the admins kind of see it. It's already preloaded, easy for me to go and execute. I just script, you know, that all these images are loaded on these machines. All right.
So I saw a question about configuration management tools like JFrog. You still need that, right?
So the question was, how does OpenShift work with tools like Chef, Puppet, and Ansible, right, and SaltStack? Those are probably the four most popular configuration management tools from that standpoint. So remember I said a little bit about gradients of Red Hat solutions. So at that one end is you can buy RHEL, Red Hat Linux, and there's a Docker RPM, you can install that, right? So that's kind of roll your own from that standpoint. And a lot of people, what they do is they'll just take base RHEL and I'll script my way into something like this, right? And then at the far end, OpenShift is data center in a box. We already did, you know, we smashed together like 10 some products, right, different open source products. We created all the YAMLs, we created all the JSONs, we created all the happy paths, the CI/CD process, all the images are created. So, you know, you get the end output from that standpoint. So in that terms, you don't need any of the configuration management tools because it's all built as part of it, right? There might be some scripting outside of it. so you can use it, but you know what I mean? There's a smaller need for it as opposed to when you are rolling your own PaaS or rolling your own infrastructure as a service, or even your own version of kind of like Jenkins, right?
So
CI.
configuring, yes, not just applications, but other things, can still be a configuration management tool, right?
Sorry, say that again?
If you configure things other than just an application, you can still need.
Yes, yeah, that's true. So the question was is that wouldn't there be a need for scripting outside of configuration, right? But what you kind of saw in this demo is because we own storage, it kind of automatically mounts it as an option up on the screen. Because we also own is the network layer, right? We have our own software-defined network there, right? It automatically built the VLAN for me dynamically. It automatically registered each node or each each pod with the HA proxy, right? So the thing is that you really don't need to script outside of it unless you wanted to go outside of the environment for some reason, right? But it's a full end-to-end, solution from that standpoint.
So if you're running on something else like VMware,
You can run anywhere that RHEL would run. So the thing is that if you run EXI at the bottom, you can run OpenShift on top, right? But you got to think about it is like, although that we see some companies do that, think about the case for is, first of all, is people care about from an ROI standpoint is application density. If you run EXI on the bottom of it, you're not going to have as dense an environment because you have to now pay for the penalty of virtualization. That's one. The second thing most people care about on VM is really around is DR with vMotion, right? But now if you're in containers, do you really care about vMotion, right? It's really your data that's the most important thing that gets moved around, right? You don't need to go and vMotion the OS, the apps, right? From that standpoint, and because also the networking layer has automatically been automated for you, you go and do that, right? So there's a lot of reasons, a lot of our thinking behind why we did what we did, right? And not to say that you can't build this yourself, right? But I think once you start seeing is all the various pieces that you had to go build and glue and do whatever it is, right? Then there's value from that standpoint. So the other thing is that what I wanted to go share, since we're all techies from that standpoint, is that there is a Vagrant image that I can go and share with you. So you can go and download it. It actually uses the community version of our code base, so you don't have to have a subscription and license key from that standpoint. If you use is that image, you can do everything that I did. But what it will be a single Vagrant image that has that's a node and also is the orchestration, right? So you're gonna run everything like me. I'm running both components on 4 gigabytes on my machine, right? In VirtualBox, right? So you can go play around with it from that standpoint. I also have instructions to kind of separate the two, then you can actually run multiple VMs and see how the way it works, right? But you can also easily add more capacity from that standpoint if you want to go and do it. But the best way to get your hands dirty with something like this is really around is playing it for yourself, right? And when you go and see how the way it actually provisions out like Node.js, Java, all this other stuff, I think you'll find it very interesting. It's like, if you had to go and do it yourself, why would you just want only an OS, right? I mean, literally with something like this, and we have a hosted version of this that you pay per hour, so it's called OpenShift Online, right? I mean, literally, if you have is a login to the system, and I have a bit of code that I want to do, whether it's Wildfly Swarm, which is our opinionated Java framework from that standpoint, or any of the JBoss software, or anything, not even in Java from that standpoint. Basically in 3 minutes, 5 minutes, you can have a full 20-node cluster, right? And you have full CI/CD already built on it, right? Well, you don't have like with Selenium, and you have to port your JUnit. You know what I mean? But it's the whole idea. You get us a full environment that you can be able to start building your code on out, right? Fully secured, backed up from a security standpoint with SE Linux. Performance, high performance tested, and if you wanted any of the modules to be plugged on out, like a lot of people, we have a commercial version plugin for F5 instead of using the HA proxy, right, which will create IP pools and whatnot. You can go and do that. So wanted to also talk about a little bit about some of the books, right, that I will also share with Paul. So we have 2 books, third book actually that we just put on out. So we wrote this book with Google. It's called Kubernetes Scheduling a Cloud of the Future. It's a great read. It talks about the philosophy, how it actually is built, what it's trying to go solve. And then we also have the Docker Security book, which is about 50, 60 pages. These are free, and it really talks about, if you have to run this as scale, right? Not single instance, but really run it in production. Here are some of the architectural decisions that you have to go think about in order to go and make it happen. All right. So that's it. Thank you for humoring me from that standpoint with my little snafu. I'll definitely send all this information to Paul itself. John and I are welcome to answer any questions. And yet again, John is the product manager for our microservices strategy. He also came from Sun as the Glassfish product manager and also Java EE. So he has a wealth of information from that standpoint. I'm the gearhead, so feel free to go and ask me questions about the product itself and about Docker and about what we're trying to go solve in this space. Thank you.
Okay. Do we have any final questions for Albert or even John? Okay, so, oh, I'm sorry, I have questions.
So there was a lot of discussion around applications and application immutability and that kind of stuff. What about the database? We saw just like a little bit, you see, we attach storage through an image that has MySQL installed. How does that function as you try to scale something up?
So the question was, how do you scale something like a database, right? So there are various options. Like the one that you saw that I showed was MySQL backed up with persistent storage, right? So unfortunately, here's the caveat that you have. So a lot of the traditional databases only work as client-server, right, or master-slave, right? For them, even though we can Dockerize the application, right, fundamentally, it's not built in a distributed manner, right? So what people do is they typically do a blend, right? So they'll have as a Docker image that actually, maybe 2 Docker images that are provisioned out as a pair. And it will be configured as a master-slave or takeover from that standpoint, right? The other thing that they go and do is they have a separate second set of images that's really NoSQL, right? And from NoSQL standpoint, it's much more easier to scale out horizontally, right? So you have a Docker image that is self-aware. Now, I've heard, and I have not played around with this, but companies like, projects like MySQL and Postgres are coming out with a new feature that mimics some of the, I would say, cluster-aware type of architectures that are very similar to NoSQL, right? I haven't personally played around with it, but they're trying to get also in that space to be able to go do that. So, a better or a slightly different way of achieving something like what Oracle Rack may do, right?
Do you have some sort of a VPN tunnel to your data center?
Yeah, VPN connection to your own data center. Yeah, that's outside of OpenShift, right? That's just standard networking from that standpoint, right? So what typically they'll go do is they'll have OpenShift and they'll give it a URL, like something star.cloud.example.com, right? So that it knows that that entry point, when they provision applications, right, they'll have that type of URL moniker or URI that's associated. And there's a reason also what we did too was that we have our own built-in DNS. And the reason why is that when you're bringing up containers, right, you kind of looked at, I'm not sure if you saw the screens, but it actually had no name on them. So the virtual IP has a name, Monster Demo, but the container name was something like 73x54, whatever it is, from that point of view. Because you should never know what is really behind the scenes, right? And so that allows you to kind of abstract away some of the scalability or networking issues that you might have. Other questions? You guys are so quiet, other than for me not making my demo work the first time, right?
Okay, I got a quick one.
All right.
In the scale example, this is probably nitpicking. The scale example, you have the OpenShift UI that showed the running Docker images, but you had to go to a command line to scale. How come we couldn't do that from the UI?
Oh yeah. So the thing is that there is a way for you to go and do that. I just didn't show it.
Okay.
Yeah. So I wanted to show you a little bit about because we're a technical audience. I wanted to show you more of the command line. Like we can truly do everything through the command line, right? We also have a REST interface from that standpoint. Usually, I mean, most people they want to go see is like, okay, here's the image. I click on the image, it automatically provisions out. Magic sauce happens, and here's the image, right? From that standpoint, right? You never even see the Maven build, right? If I didn't even go behind the scenes, you wouldn't even know that it was Maven. And you can already see like where I was executing the pod infrastructure. You can kind of see that, oh, here's the pod for a build, here's a pod for the deploy, here's the pod that's running for EAP, and then another pod that was running for the database itself, right? Most of the guys, for us as developers, who do we care, right? Somehow it's scaled, right? Yeah, it's giving a response back on the web, right?